All right, the homework on page 92, those tricky vectors. So, in problem number 1, they tell you that a football player runs straight downfield for 35 yards. Then the football player angles to his right by 25 degrees for 15 meters. So he kind of does this. Here's your 25 degrees off of the supposed forward path. Then our overall answer is going to be represented by this large blue line. To get that, we want to form a big triangle here. So we need to calculate, let me get rid of the imaginary line here, move that kind of there, put this imaginary line kind of there. We need to calculate this blue vector here and this blue vector here, because what that means is the diagonal one is broken down into horizontal and vertical components. So using the 25 degrees and the 15 meters, use SOHCAHTOA to calculate this and this. I believe they come out to be roughly 13.6 and 6.3. Then you have a big triangle. You do the 35 and the 13.6 squared and the 6.3 squared, and you get an answer. Then problem number 2, I believe, was the airplane taking off problem. And they say the airplane takes off at a very exaggerated 35 degrees to the ground for, I don't know, 2.5 kilometers. And then the airplane changes its angle. Now, they're not going to have the airplane crashing. They're going to have the airplane just kind of leveling off a little bit for 5.2 kilometers, I think, something like that, at 22 degrees as compared to the ground. So you kind of want to throw in there's the ground, 22 degrees compared to the ground. Now, again, we're going to take the two black vectors and break them into horizontal and vertical components. So this first one, there's the vertical component, here is the horizontal component. Then you're going to have the vertical and horizontal components. If you break that down using SOHCAHTOA, you'll get those 4 red lines. Our end result will be by calculating this will be the end result. I'm going to pull it off to the side for a second. Once you calculate the red lines, you can sort of quit thinking about those red lines right there, the 2 component vectors, and stop thinking about the angled ones, and just think about this. Now, if you want to make a triangle out of this, that's kind of goofy. What if you pull this one over to here and drop this one down? Now you got a beautiful right triangle that you can calculate with, 3, 4 known numbers here. Whoops, go back. Use Pythagorean theorem to solve that. And the rodeo clown, he runs 3 ways. He runs first straight north, then he runs at a 55-degree angle, if I'm not mistaken, east of north, and then he runs straight sideways again. East of north, meaning from your north, he runs 55 degrees east of north. So the angle is going to be 55 degrees up here, unless I'm reading wrong. Oh, I might be remembering incorrectly. It might be, if it says east of north, it's right here. If it says north of east, it's right there. You got to look at what it says in the book, guys. I'm not remembering. So in the end, you need to take that angle using the 55 degrees written in the proper location and make 2 little triangles out of it like this. Make a triangle. Now you can use the hypotenuse and the angle, whichever one it's given. I think I'm remembering it's this one, 55 degrees here, which would also be 55 degrees up here. Make a triangle out of that, and therefore know the eastern motion and the northern motion of the rodeo clown, and then you find that. For number 4, you will have to do this airplane question. And with the airplane, it starts out here, and I believe it goes 30 degrees, I think it says north of west. If that's the case, here's your 30 degrees. Then it says the plane then goes 60 degrees east of north. So there's this huge 60 degrees here. So with those two things given, you need to break it into two triangles. You need to take your angles and make a triangle here. And then you got to use the angle and make a triangle here. Therefore, you can get the answer represented by the red line I'm about to draw right there. Now, what you're going to do is you're going to find the blue and the blue, and the blue and the blue, and you'll add north plus north to give you the overall north, which would be equal to this one I'm about to draw right here. That would be the same. And then you're going to get the big eastern line minus the small western line to get this arrow here. Good luck.